Let's take a look at a special case of dipole-dipole interaction. And that special case arises when hydrogen is the positive dipole in the polar molecule. An example of this can be seen with water. And this is going to explain why we saw that ballooning in the demonstration I did before, where the water rose above the surface of the container. Let's look at a molecule of water and then see how it relates to other molecules of water. Here's our model of a water molecule, and here is a collection of a number of water molecules. So what's going to happen with these water molecules? Well, hydrogen we said is a special case here when it's the positive dipole. So this hydrogen is partial positive, so is this one, and the oxygen therefore is partial negative. So hydrogen, when it gives its electrons to a shared pair bond, it's a pure proton left over because hydrogen is only one proton, one electron. So when it gives away that electron to the bond, it's just a proton that's left over, which is a significant source of positive charge. So this is about just as partial of a positive charge you can get without being a full positive charge. So let's show where these attractions are going to take place for this molecule. We're going to have attractions between the hydrogen of one atom and the oxygen of another, like this. Here's another branch, and then we're going to have a connection that way. We're going to see a network going like this and there. Now this case of dipole-dipole interaction, when hydrogen is the positive dipole, is called hydrogen bonding. And hydrogen bonding is significantly stronger than regular dipole-dipole interactions because the degree of polarity with hydrogen being the positive dipole is a lot higher. So hydrogen bonding is our strongest form of intermolecular forces. Now it's important to note that even though we call it hydrogen bonding, this is not a true bond. It's just a way of talking about a very strong intermolecular force. So these are the two cases of intermolecular forces that can come up with polar molecules.